Did you get the Dropbox link? Okay.
So did you all get my information about installing T-Splines?
Yeah.
Okay, who has used T-Splines before? Nobody? Well, that's gonna be fun. It's actually quite an exciting little tool. I wanted to go for paneling tools, a few little things that we left out. Because remember, we started going through the paneling tools quite nicely, but we never got to the poly surfaces and how to do this. Let's see if they're loading right now. No, they are. Fantastic. So I'm gonna go back here into my file quickly. I'm gonna sit down for the same reason. Going into my layers, open up quickly my layer 3 and what is the other one? No, this is not the other one. And my layer 2. Turn those two on for the sake of it. Yeah? You guys have the file still, right? The old file we used last time? Yeah. Okay. What's going on here is, as you can see here, and I'm following pretty much like the tutorial that you can also find online if you had a pleasure to look for it. Actually, it's pretty straightforward. And this is just symptomatic of, that is just one example of a poly surface. You can actually redraw any type of poly surface as you please right now if you want to test it. Yeah? But what it is basically, you see here, this is 3 different distinct surfaces. If I would join them, it would still be a poly surface. You get the idea here. I just kept them separate so I can describe to you that it's selected. So what we want to do is we want to create a grid on top of this and want to populate it with one object. Yeah, we're going to use a slightly different technique than we usually use. So what we do for this is first we need to create a grid. So this the tricky thing about creating a grid on a poly surface is you can't actually really select the poly surface. Yeah? So you would need to, so if you now do a paneling grid, let's do a typical surface domain number for the sake of it. I would need to confirm for every surface my grid. That doesn't help me because I need one group. Yeah? I also need the whole surface. It might have different, if I have a joint surface as this one would be, I might even have different U and V coordinates on the surface. Remember, we had this issue when we were looking originally about trimmed surface and untrimmed surface related things. So that's not good. Yeah? So we can't use our typical paneling system. So what you want to do is you actually want to first literally draw a grid onto the surface. And the way you do this is by actually using curves as the reference for the grid. So I'm quickly going to go in top view, and I'm going to quickly turn on here just for the sake you guys get that this is the top view. My shading, I can get rid of these guys in the meantime. I'm just going to quickly hide them so we're not going to confuse ourselves. Oops, right? We're also hiding those gray ones just quickly. So as you can see, I have here oriented parallel lines. So the only reason why, oops, sorry about this. The only reason why they're kind of at an angle is because I just want to prove a point. There's no other reason. It's just for demonstration purposes. And the reason why there are only 3 lines is also simply for demonstration purposes. Yeah, so there can be any type of amount of line. Why this is for demonstration purposes, as you can see, they will likely gonna hit not always only this one surface, but also the other surface. So I will get actually polylines that have joints when I project those onto the things. Because my method that I'm using to bring this onto this poly surface here, yeah, is to project. And I'm doing this from the top view because I'm here perpendicular to my top view T-plane. And as you know, when I'm in my planar views, like left, front, right, top, bottom, I actually can project without actually needing to have the object above or below. It just does it by itself. It's different when you're in the perspective view. Yeah? So perspective view is always a bit of a special treatment in Rhino, so it's much cooler to do stuff here sometimes. Yeah. So we're gonna just project those three lines. Look, go project. Project. We should invent words for Rhino, right? Yeah. Maybe that's one of the exercises we could do. Okay. I'm gonna select the three surfaces I have here. Yeah. Loose, no, delete input, no, doesn't really matter. Output layer is totally fine if it's the current one. Yeah. Hit enter. What it does automatically when I go back before I deselect and going back and see, it makes actually nice little curves all around my little ring. That's the nice advantage of projecting in planar views. Yeah? Before you unselect them or deselect them, join them quickly. Because, as you might know, if one curve hits a dead end at one surface, it technically stops and continues into the next curve. Yeah? Unless you join them. So we want to join them just for the sake of it. Yeah? So there were some unjoined curves. Yeah? We have some curves here too. So the nice thing is right now is that I didn't select all the polysurfaces because I don't need those projections on the inside. I just want to demonstrate it on the outside. So what we have now is we have three curves that can form the basis of a grid, because that's technically all I need. Because when I look very carefully at my paneling tools, at my grid tools, I can divide an array of curves, for example, into points. Yeah. I could extrude along one curve. I could array in general, but I can just divide an array of curves that sounds like a perfect solution to me. I could also get into any other thing. So what I'm doing now is this. So I'm noticing something though, that there is here a bit of a jog going on here in the way my points are organized. It has to do with the different lengths, with the different starting point of my curve. So if I'm accepting this, now let's make sure that we group them, yeah, because otherwise it's going to be really complicated. The chord length, we can change the method to any other type of method. You can go by arc length or by numbers simply. Let's do just the number just to be safe. We're going to go here for like, let's say 80. Yeah, that gives us a good number. Might be better with 90, but let's say 80 is fine. Yeah. Make sure it's grouping. The name of the grid is irrelevant for now. Yeah, hit enter. So what I'm getting now is when I click here this group on, and I will just test it, just for test purposes. You guys see everything that I'm seeing? Sorry, my mouse does some weird zooming sometimes. Yeah. Paneling tools, let's create quickly a paneling, a 2D grid just to test if this is a clean set of points. Actually. And what you will see is we don't need a base surface right now, so we could pick this one. But what you see is something quite disturbing here, and it's kind of cool, yeah? But it's actually not what we want, because we want actually the grid only distributed along those curves, yeah? So they are actually going from here to here to here to here and all over the region, and it doesn't look too good. So this is a no-no. So this was a not good set of points, and the reason why this is not a good set of points is simply to do. If I may sketch this up for you quickly, and this is something you have to understand is if I have, let's say I have here two surfaces, yeah, I'm just drawing two surfaces, yeah, and I'm projecting a line onto it, then it changes a curve here, this is my curve 1, and a continuous curve here, this is my curve 2. And if I put this further out, then have another line that is the same thing, yeah. So what happens is simply is if I join them, my start point might either end up here, or here, or here. I don't know that. Yeah? The length might start counting from somewhere weird. Yeah, it might just simply say that when I joined it, it started counting for this curve here, and for the other one, it started here. So I have this weird condition going on right now that I need to adjust my curve seams, actually. Yeah? This means before I even start setting up the grid, this is something you will likely encounter in any type of polysurface when you project the lines onto it. Yeah? You will have to adjust your curve seams so they all have the same start point and they all look into the same direction. That's a command I personally constantly forget. Yeah? And I always wonder, how did I do that? How do we do this? It's just because it's one of those things you actually really want to use when you need it, but you don't use it that often. Yeah. So that's why I'm bringing it up. So the command is curve seam, and this CRV is a very useful command. CRV seam. Yeah. Seam. Yeah, like seamstress. Yeah. Yeah. So you adjust the base, and you can. There's multiple types of commands. So what you type in is CRV seam. Yeah. So actually, before we do this, I want to quickly get rid of the old group, which was pointless. CRVC, yeah, and then I'm going to select all the three curves at the same time because I want to adjust the seams more or less at the same time. Yeah. Hit enter. So now, as you can see, my starting points are being adjusted to all in one location. They're all pointing in the same direction, and they're all starting pretty much at the same location. So this is nice, okay? Because now I can start my curve direction. You guys probably have this problem before already. Yeah, when you have those one curve points one direction, the other curve points the other direction, you get those weird conditions and you don't know what to do. Here's the command for it. Yeah. You can reorient basically your start point and your starting direction on the curve. Yeah. Very useful. I can constantly keep forgetting it, so I wanted to show you this little command. It goes on. So now we're good. So we click OK. We can just do it automatic. It's perfectly fine. We could flip it also to go the other direction, but you can also see you can actually manually adjust it too. So just clicking on those things, you can flip them all, or you can flip them individually by just when you get this little black arrow. So now they're pointing in different directions. I can do this for this one. You kind of need to hit the top of the arrow, I think, about this. Yeah. And that's perfectly fine to go from the other direction. For me, it was important that they're kind of lining up and that they are starting at pretty much the same area and pointing in the same direction. That's all I need at this point. Yeah? Any questions so far? Pretty straightforward, right? So now when we start doing our array, pretty simple. Create paneling grid, we create a divided array of curves. Yeah. Now we see it's actually pretty nice lined up everything now because we go by number. Yeah. So it's all good. And we hit enter, we group this, it's grouped perfect. So what are we doing next, guys? Well, actually, we could even do a 3D grid. Let's do a 3D grid. Okay, fair enough. We got some advocacy here. What I told you in the past is I said you can't really do a 3D grid without more than without a 4 corner points, cell points, right? That's not exactly true. Yeah? The reason why this is not exactly true because there is also a command that allows you to orient the shape within the grid onto a circle or grid base. Yeah? And that's what we're going to be using right now. Yeah? So accept this. So what we do now is paneling from grid, orient a 2D or a 3D module to the grid. Since our grid follows the surface, it automatically then, for this reason, it orients itself. It doesn't deform to the surface curvature, but it orients itself to the core grid cell point. Okay? So this way, actually, you can retain the shape of your object at the same time as well. And the size of your object depends not only on the grid cell size. So you get a bit more control over the deformations you might encounter possibly. Yeah. Follow me on that? You're all bored? Yeah. Okay, you can yell at me for some improvements. We should do like a kind of like a list of improvements I should make. But also feel free if you have questions about the Rhino or something like this. Just make sure you ask me also or your colleagues. I just want to also remind you, since you supposedly have purchased Rhino copies, right? Right. Right. Okay. So since you have purchased copy, I would like you to take advantage also of the news groups and forums they have. Again, Rhino is famous for being a very open source sharing community. Problems are happily and openly discussed by the developers and by the people working with Rhino extensively. So you shouldn't be shy of those type of things. Yeah? Just letting you know. Yeah? Everybody must start from somewhere. So let's do this module. So our module, I'll just take this guy here because I have actually my reference plane there somewhere else, so I can actually submerge it into the surface. Okay, so module object, it entered the origin point for the module. That's now a bit tricky, yeah, because I want to make sure that I have a good origin point. I can pick one of those corners, for example. I should probably pick my center point because then it's actually also centered to myself. We'll find out, obviously. Yeah. So let's just pick one of the corners of this lifted rectangle. You can take the other shape too if you want. Okay. X direction, remember we also do this, and then we have a Y direction, so that's identified. The Z direction is perfectly fine in this direction. I could flip this down too if I want to, so it's upside down. But that's fine for me. Enter. And then it asks me for a grid, which will be this group here. And then let's see what it does. Select enter base 0, base V0, that's fine. Shift, we do a simple shift. We don't need more than one because we have basically 4 corners, so we have our cell adjacent to each other. We don't need to extend our U and V for now. Yeah, we could look at this. Hit enter. Do we have a base surface or polysurface? Mine are not joined, so I might get some good result possibly, but let's say this is my base. And it nicely populates it, as you can see, with my center of my object actually being a bit offset here, because when it asks me for my origin point, I should pick the center of my object, actually. Yeah. So I missed that part, but actually what it does nicely, it populates onto my surface, and it retains actually also the sizing of it. So it's kind of like nice, controllable distribution of objects on surface. You got that? Yeah. Okay, so you get the idea. There's other ways you can treat those type of grids and so forth too. There's lots more tutorials on more complex surface operations with paneling tools. Yeah? I'm not going to go too deep into paneling tools. It's a very useful, quick fix for a lot of things. Of course, if you want to become smarter in your Rhino usage, you go very quickly into Grasshopper with paneling, because that's where it becomes a bit more interesting. But we're not going to get to this probably this quarter, so we're going to do this next quarter. Yeah? And you will have me again. Yeah? I'm just warning you guys. I'm warning you. Yeah? Okay, so you all good here? Anything I need to repeat? Anything you didn't get? It was pretty easy, right? Okay, good. So why do you think we're looking at paneling tools in general?
That's what I just asked.
Huh?
That's what I just asked. I mean, why are we doing this for?
Okay. Do you have an answer for that?
No.
Do you think you have any application for that? Huh?
I think it has to do with some sort of introduction for us to start thinking in terms of grasshopper within Rhino, and that's one possibility, because if you are to build something that's responsive to its environment, grasshopper is building changing facade, say responsive to the sun, power it or whatever, cool it down, then that's what you need to do.
And that's one thing, and also you have to understand how big is a typical drywall panel.
8x4.
Yeah. There's 5x10 obviously also, yeah. But 4x8 is a typical drywall panel. How tall are typically buildings? Huh? Let's say a 3-story office building. Yeah, so how many panels would we need to have for that? So let's say you don't want to do drywall panels, you might need to do facades. Right? You really want to do this all on foot, like draw every panel or something like this? Yeah. So I think you need to start thinking in operations, like actually your buildings you're designing right now, they are actually fairly material-less. Yeah, like what we have been so far pushing, except for I think the last exercise in your first year, in Springport, were mostly facade-less and mostly also material-less. There was kind of like a stacking component sometimes involved, which has a lot to do with this too, to a degree. But actually everything has to break down into material that can be transported, can be lifted, can be put in place, and can be also replaced. Yeah? So that's why those type of tools are actually extremely useful. Yeah? Because you have to plan actually in those type of systems. And at the same time, you might have started laser cutting some more complex curvature shapes. Right? How do you break it down? Well, remember, we looked at this briefly. You can actually nicely subdivide like a complex curvature panel into triangular pieces or even into quad panels and then laser cut. Put it together. Yeah, so there's a couple more tools. I haven't gotten to it yet because there's something I wanted to point out to you. There's also tagging and so forth, which we can't really get to. What's really nice is tabs, yeah, which gives you some lamination tabs if you unroll something for each of the pieces, so you can actually overlap them nicely, so you can glue them together if you do something paper, or if you might want to make coffer panels out of it. So just test this out for your own sake. There's tutorials for all those type of things out there. I'm just giving you a basic introduction for those things. Yeah, you can start applying them for your own sake. And of course, I might write an exercise which requires your skills. Because that's always the best way to test it, right? Synthesis. Yeah? All right. So let's go to our next little tool. Have you all installed now the T-Splines? Okay. So remember when I gave you the introductions about half a life per way? Yeah, right? You probably don't even recall when we had our first class because things are moving too fast. But it was only 5 weeks ago. I talked about types of modeling, right? And types of modelers. Do you kind of recall this? Where I talked about solid modelers, polygonal modelers, NURBS, right? What is NURBS standing for? In and out it goes. All right. Non-uniform rational T-splines, not T-splines, yeah. B stands either for Bézier or Ben splines, yeah. Bézier was a mathematician, etc. But then I talked also about something that I've only brushed on, which was what? Well, A, that NURBS is a really cool cat name, and B, that we also have subdivision paneling, yeah. So subdivision paneling or modeling is actually something that is becoming more and more popular, partially because it is a very nice way of modeling very freely. Like it's literally like clay forming and modeling, but without kind of like overutilizing the geometries, which means you only have algorithms running basically that do a lot of work for you in terms of deforming or shaping certain things. So I'm going to show you a quick intro into this piece. We don't get much out of it. Like we have 10 more minutes, so I'm going to show you a quick introduction to it. I'm going to prepare a little home lesson for you guys. Like, yeah, I'm going to get better on this, I promise. Okay. We're going to repeat something then in 2 weeks, I guess, on this, and then we move right on to rendering, yeah, with a little exercise in between. So we're going to be all render fairies by the end of the. Well, renderings happen usually overnight, right? That's why it's like a magic fairy. It's like the two fairies, like the render fairy. So you become all here, or visit, whatever you want. You become magical render elements, the creatures, by the end of this year, hopefully. Yeah? Okay, then we move on in 5.5.2 with adding a bit more information to rendering, editing, do a bit more descriptive geometry gadgets, like how to actually use perspective in a more interesting way also. Probably look at the anaglyph type thing so you can render in 3D and stuff like this. And just some fun parts and obviously grasshopper. So we have a pretty good scope for the next 2 quarters. So stick around. There will be a sequel. Let's go quickly for these type of things. So I have my commands all here. It's kind of weird that it's called all commands, but that's what it is. You have multiple toolbars. Ignore this toolbar. That's one of my special toolbars, which I have just some tools I use sometimes. You will hear about them later on next quarter. There's one toolbar that you should have here. This is the HED interface, which is very necessary. Yeah? And then you have here a standard toolbar. So what you have to understand is that T-Splines is a bit of a hybrid between mesh modeling and NURBS modeling. And that's the tricky portion of it. So it's actually a standalone piece, yeah, but it translates your object back into NURBS while it actually does mesh modeling. Yeah? So it's a really weird hybridization of this. That's why it's its own piece and stuff. Let's go in there. So what we can do in our all command scenario, let's quickly create a box that is coming out of T-Splines. Yeah? So just click down here. You can create your own geometry in T-Splines. Yeah? Oops. No, just create it. So we just draw a box and pull it in. So what happens, and then turn on our T is shiny because that's really nice. They have a shiny shader actually, and you will understand why you will need it because it shows you actually nicely when your purges are unneeded. So the T is shiny. So our box doesn't actually look like a box. It looks more like a marshmallow type thing. Tofu block, clay, cheese block, whatever you call it. Something. So we can't really do much with it. We can still do the same transformation as we always can do. We can rotate it, move it around, and so forth. And what we're going to do now is we're going to enable our HOD just for the sake of it. So once we enable this, you guys are following me? Okay. You're going to have some fun here, okay? So, want to quickly, you get actually another gizmo going on here, another gumball type thing that will be laid on top of your actual gumball. So if you get confused, just turn off your regular gumball for the sake of it. I'm going to have them usually overlaid because it's going to work this way anyways best. So now here we have our translate tool, which means everything which is moving or copying are translations. Yeah, that's by definition. That's mathematical. We have our rotate, we have our scale tool, we have our pivot orientation tool, and then we have here something curious. Vertices selection tool, we have an edge selection tool, we have a base selection tool, and we have an object selection tool. And then we have a few other things I'm going to get to later. Let's try quickly for the sake of this, our base selection tool. So now you can see that we have actually access to what we never had access before. Our discrete subsurfaces. That's why it's called subdivision. So if you select it and then start just simply pulling it, yeah. Ooh. Alright? You can see how cool this gets very quickly, right? So here's what's running in the background, because it's nice, right? I'll show you a couple quick remote tricks, so pay attention and stop the chatter here somewhere. Okay? Alright. So what happens here actually, you can turn on, turn off this visually also. When you click on this, the smooth toggle, the smoothing again is an algorithm. Yeah? So you can turn on, turn off. What you see here is that this is actually underlying a mesh object, where you pull and transform the mesh elements that then get smoothed out by an algorithm. And you have some influence on the degree of modifications. Yes, sir?
How do you get the lines up here on the shape?
Which lines appear in the shape?
The grid?
Oh, I drew a box that automatically comes with it. It's a whole package deal. You don't have this?
I just have the shape, but I don't have the.
Oh, so you drew the TS box basically, and it doesn't come with anything.
Yeah.
Did you set? Did you look how many faces it actually asked for?
When I move the mouse around the object, it gets highlighted.
Oh, I turned on my HUD and then I selected my face here. Down here, like you need to get this little bar up here, like when your HUD you need to get up. Yeah. Are you the only one who is having this problem?
You have to click a little power button.
Alright. We're resolving this issue. So your HUD is actually here. This is your edit mode icon here. Right under the green on button is your edit mode icon. Yeah? You have a discrete editor. You have your own separate editor for T-Splines. That's something you have to get used to. Yeah? Okay, let's do something else. We can do this obviously with the edges as well, right? And we can pull just simply edges and move those around. So we can also obviously add edges. That's actually the nice thing, but that's actually really cool. So I'm going to insert an edge right now. I'm going to show you how this works. So I'm going to just pick up one edge on another edge and hit enter. And then I can just position it somewhere where it deems it to be okay. That's a bit tricky because it's not going to be anywhere. It kind of has to be somewhere where the software deems it okay. Yeah? And that has to do with what is running in the background. So what's happening now I have multiple faces where I used to have one. Yeah? So now I can go back and actually pull this face. Yeah? Or just this edge. Or I can even go ahead and delete this face. But what's happening then is it loses some information, some smoothing information. So what we have to do now is actually we have to now go in here, select our edges, yeah? And then we switch to our scaling one. Yeah? Hold down the Alt key and just duplicate those edges. And it makes this nice little hole. And we fix the shape again. That was pretty cool. So obviously you can just click on this one edge, double click on it, and it gets the entire double edge ring, like a continuous ring of it. And if I hold the Alt key and just translate it, yeah, by moving, I can create more and more of those type of things. Yeah? I try this again here. Okay, let's start over again. Yeah? We delete this guy here, so it jolts up because what it misses is like surface information that give you the rounding off. So in order to regain this information, is we need to select the edges. We go here on the edge selection tool. Make sure you select the red one. These ones we need to duplicate in order to get actually away from our creased edge. Yeah? That's the tricky portion. So in order to duplicate it, we want to just scale them inside. Yeah? And you can do this by holding down the Alt key, and here you see like you have a little translation icons when it has multiple axes. Yeah, like this is C and X, this is C and Y, this is X and Y. I do just X and Y. Hold down the Alt key so I make a duplicate of this edge, which automatically creates this condition. Pretty cool, right?
What if you don't want to make a whole one, like catch that?
Oh, you can. You can. Hold on, I'm not done. So I can sense you're getting really excited to call your cat now subdivision. Yeah. His nerves is far less cooler. Yeah. So what I'm going to do quickly, I'm going to show you also another nice little feature here. Yeah. Let's try to orient those quickly to each other. We are about to be finished. So I'm just going to move this a bit closer to here. I'm going to quickly check those two objects. Okay, so I'm going to select my edges. I double click on them so I get the full circle here. Once I selected one, select this edge, and then I'm going to go here and find my bridging tool. Yeah? There's somewhere a bridging tool. Bridge, which is this one. We already have selected our edges. Now we need to make sure that they're all oriented in the same direction. Remember, we just had this with our curved seam thing, so that's important here too. That's fine. And now it starts nicely connected. Of course, it is important that you have the same amount of edges to match up to the next same amount of edges. So the same rule as we have with the paneling tools and so forth applies. Yeah? It's pretty neat, right? Okay, let's go for something else quickly for the last presentation. What I'm going to do is I'm going to draw here like an edgy line. I'm going to draw another line somewhere here. I'm going to go up here with one line. What I'm going to do now is I'm going to make this a little network of curves, and I'm going to quickly pipe them to these curves. Yeah. So that's the cool thing here is that you can see. Oh wait, cancel. That was the wrong one. Wrong command. So what I can do now, let me quickly treat this. Okay. I can pipe this. And the nice thing about it is it actually touches all of them, and I can adjust, obviously, I can adjust those angles, curve positions. I can decrease those angles by scaling them, I think, and so forth. But I can also hit enter. And once this is done, oops, it's one object, and once I'm toggling this back into smooth, it actually makes a nice smooth connected thing out of simple, discrete lines. Yeah? And you can scale them discretely and so forth. It's kind of nice, right? Okay, so play with this a bit. We're gonna give you a bit more, gonna walk you a bit through more exercises with this. But it's a nice little feature and tool, and thank you very much for showing that. Sign up sheet to me.
What?
Questions asked. Huh? Yes, sir.